We'll now discuss sequential operations, which are used when writing up algorithms. The first question we should be asking is, what is a sequential operation? Well, it's basically an instruction. That's it. And when it comes to algorithms, there are three basic sequential operations that we're going to go into more details. So we have the computation instruction, we have input, and we have output. A computation instruction just involves doing some type of computation, and then we take that result and store it somewhere. We save it somewhere. So here is an example, at least a format of such a computation instruction. So we would say, set the value of variable, where variables in quotes, to arithmetic expression, which here we're just using quotes as kind of a placeholder. That's normally not used in algorithms. But the whole point with this instruction is that we would evaluate the arithmetic expression, and that's going to give us some result. And then we're going to store it in what we call here the variable. So what's a variable? You probably heard of this in your math classes, and it's sort of similar to what you see in math classes, but not quite. So in computer science, a variable is a named storage location that's going to hold some data value. So that's all we're doing here. So we're going to do some computation, and we're going to take the result and store it in some variable. So that will contain some value that we can use later on in our algorithms. So let me just go over a couple of examples just to show you how this would work. So maybe we would have an instruction that says, set the value of carry to 0. So in this case, the number 0 would be stored in the variable carry. So here's another example. Set the value of C to A plus B in parentheses. So what this means is that we're going to evaluate A plus B, and here we're assuming that A and B already have values in them. So like, for example, maybe they have 5 and 7. Maybe in this case we have A equals 5 and B equals 7. So let's just use that as an example. So in this case, when we evaluate A plus B, we're really evaluating 5 plus 7. So that's going to give us 12, because last time I checked, 5 plus 7 is 12. Yep, that is correct. And then we're going to store that result in C. So when this is all done, C is going to contain the value 12. Input and output instructions to simply allow us to communicate with the computer. That's all we're doing. So we need some way of interacting with the computer, so we use input and output instructions. So input operations provide the computer with data values. So these instructions, these operations, allow us to give data to the computer. And then output instructions or output operations send the results back to the user. And the way we would handle this is we normally use different types of input-output devices to communicate back and forth with the computer and the user. So just to give a couple examples, the keyboard and the mouse would be input devices. So we can type something on the keyboard or click something on the mouse, and that sends input to the computer. We can use the monitor or the printer as output devices, because our monitor would display the result of some computation, or our printer can take the output and put it onto a piece of paper. When it comes to writing our algorithms, we really don't care how the input and output are done. All we care about is just that we do it, because the way input and output are handled are vary by programming language. It's different how we do it in Java, it's different how we do it in C++, it's different how we do it in some other language. So when we write it up, all we just care about is just saying, get the input, get the output. So like with input, for example, we would just say something like, get the values for a variable, and then another variable, and so forth. So we may say something like, get the value for r, which would be the radius of a circle. And then for output, we would just say, print the values of some variable or another variable, or however many other variables that we want to output or print. We don't care how that's done. We just say in our algorithm that at this step, we're going to print it. So like, for example, we may say, print the value of area, where area would be another variable. Now we can also have our output instructions display messages and not just print variables. So like, for example, we could say something like, print the message, sorry, no answers were computed. So not only can we print variables, but we can print text and messages for the user as well. Using these three different types of instructions, let's do a very simple example of an algorithm where we would compute the average miles per gallon. So the first step is that we need to do some form of input. We need to store some values in variables. So we're going to say, get the values for gallons used, starting mileage, and ending mileage. So in this case, we have three different variables called gallons used, starting mileage, and ending mileage. We're going to input those somehow. It could be through the keyboard, it could be through something else. We don't really care. It's just that we're going to assume that there are now values in these three different variables. The next step is to do some type of computation. So we're going to set the value of distance driven to ending mileage minus starting mileage. So we need to get figure out how far we've gone. So we take the value of our ending mileage, subtract it by the value of starting mileage. We're going to take that result and store it in distance driven. The next step would be to set the value of average miles per gallon. So the way we do this is we compute the distance driven, which we've already done in step 2, and we divide it by gallons used. So once we've done that division, we take that result and we store it in average miles per gallon, which is another variable that we would have in our code or our program that we would eventually write. And then we would print the value of average miles per gallon. So now we're doing some output. So whether that's through the monitor, whether that's through the printer, whether that's through something else, we're not too worried about. We're just going to say that we're going to print this value, and then we stop. And that's pretty much it. In fact, most of our algorithms is always going to involve these three different types of steps where we need to do some type of user input, we do some type of computation and store that results into some other variable, and then we output the results. I mean, this is kind of the general idea that we're going to see in most of our algorithms.